Welcome to Air Conditioning Contractors of America Manual J8 AE Speedsheet Primer. My name is Don Prather and I'm Technical Services Manager at ACCA. Manual J8 AE is an abridged version of the 8th edition of Manual J. It provides an introduction to the residential heat loss and heat gain procedures. Mastery of the material in this guide is a prerequisite for using the unabridged version of Manual J. As you can see on the right here, there's a checklist, and you need to have everything signed yes on that checklist in order to proceed. We're going to go into that in a little more detail as we move forward. Part 1 of J8, sections 1 through 10, contains the AE version. So that's the abridged edition. It's all contained in the first 10 chapters of the Manual J, the full Manual J. It also comes in a separate version that just has the AE sections. Now both versions have a checklist found next to page 1, and that checklist needs to have 100% yes answers on it, or the defaults on the program won't work, because the program is designed to go along with the hand sheets that you fill out, and there are certain defaults in there that are required in order to do it by hand or on this speed sheet. Alright, the next 14 slides are going to be a little bit boring, but hopefully we'll try to make them a little exciting here as we go, because I'm going to be talking about what the rules are that we have to follow 100% yes, and I'm going to read them to you because I want to make sure you understand what they are so you can use a speed sheet properly. The structure is a single-family detached dwelling. The total window, glass door, and skylight area does not or shall not exceed 15% of the associated floor area. The glass is or shall be equitably distributed around all sides of the dwelling. The dwelling appears to have obvious and sufficient exposure diversity. Heating and cooling is or shall be provided by a central single-zone constant volume system. The dwelling shall have no radiant heating system. The comfort conditioning system is not or shall not be equipped with a ventilation heat exchanger or a ventilating dehumidifier. Windows and glass doors have or shall have clear 1-pane, 2-pane, or 3-pane glass. The indoor design conditions shall be heating 70 degrees Fahrenheit, cooling 75-degree dry bulb, and 45%, 50%, or 55% relative humidity, unless superseded by code. The outdoor design conditions shall be equal to the table 1A exactly, unless superseded by code. Why did I say exactly? Well, some guys try and stick other numbers in there, and that's not the way to do it. If you have a problem with the numbers, they're not going to get the load right. So we need to get the load right, and I'll go into a little more detail on that later. Skylights shall be flat and shall have clear 1-pane, 2-pane, or 3-pane glass. Curbs shall default to uninsulated wood 2x4. Skylights shall not be equipped with a light shaft or an internal shade. For heating, the default U values for fenestration assemblies shall be those listed in Table 2A. For cooling, the default U values for the solar heat gain coefficient values shall be those listed in Table 3A and 3C. The foreground reflectance shall default to 0.20. All conventional windows and glass doors shall default to internal shade, medium color, blind, with slats at 45 degrees, except purpose-built daylight windows and skylights, which shall have no internal shade. What are those? Those are ones that are designed to collect the sun or never have shades that look out over a lake or something. Bug screens, French door and projection adjustments shall be made when such devices and construction are observed during the site inspection or appear on the building plans. Windows and glass doors are not or shall not be equipped with external sun screens. Overhang adjustments shall be evaluated and applied to all window and glass doors. Above grade, the dwelling has or shall have wood frame walls or empty core blocks with no metal framing, no filled core block. The exterior finish shall default to brick veneer, stucco, or siding. The interior finish shall default to gypsum board. Below grade, the dwelling has or shall have empty core block walls with or without board insulation, with or without framing and blanket insulation. Framing shall be wood, not metal, when applicable. The dwelling has or shall have a dark shingle roof over a vented attic, not encapsulated, a beam ceiling, or a roof joist ceiling. An attic or attic knee wall space is or shall be vented to FHA standards, no radiant barrier, no encapsulated foam. Slab floors shall have no edge insulation or 3 feet of vertical insulation that covers the edge. Basement floors shall default to no insulation below slab, no sensitivity to width. Floors over a closed space shall default to no insulation on the walls of the closed space. Floors over a closed space shall be insensitive to tightness of closed space. Table 5A appliance loads is 1200 or 2400 BTUs per hour. The number of occupants equals the number of bedrooms plus 1. Now that last check there, that's something a lot of people mess up on, and I'm going to point it out again later, because when you're filling out the sheet, you need to have those numbers correct. The duct system is or shall be installed in one horizontal plane, entirely in a conditioned space, in an attic that has no radiant barrier, no encapsulating foam or closed-in crawl space, or unconditioned basement. Below-floor duct runs shall default to trunk branch perimeter supplies, large return close to the air handler. Attic duct runs shall default to round, spider pattern supplies in room centers, large return close to air handler or return closet door, or rectangular trunk and branch supplies near inside walls, large return at floor of conditioned space. The duct system is or shall be sealed to the manual J default value of 0.12 to 0.24. Now credit for tighter systems requires a leakage test. Leakier systems should be sealed. Leakage greater than 0.35 to 0.70 is unacceptable. Ducts in unconditioned space have or shall have R2, R4, R6, or R8 insulation. In other words, they need to be insulated if they're in an unconditioned space. There is no engineered ventilation, or such ventilation is or shall be provided by piping outdoor air to the return side of the duct system. Pressurization effect on infiltration is ignored. No other type of ventilation system shall be installed in the dwelling. A blower heat adjustment shall be made. When manufacturer's performance data is not discounted for blower heat, the blower heat adjustment shall be 500 watts. Congratulations, you made it through the 100% yes checklist. And if you can mark everything on that list 100% yes, you're good to go. Now there's one note. A qualified practitioner may substitute a full version of the heat transfer multiplier for an abridged version of the heat transfer multiplier. What does this mean? This means in the abridged book itself, there are less heat transfer multipliers, there's less types of assemblies. So if you have an assembly number for something else, you can use it in the abridged version, and you can use it on this speed sheet. Now let's look at the speed sheets. This is the speed sheet, and they're available at www.acca.org/speedsheet. You probably already found them. Now one great thing about these that you need to remember is download them onto your computer and save them in a file or on a desktop or somewhere where you know where they are. That way, when you need one in the future, you can use it, because once you fill in all of the data on one of these, it becomes a template for other homes built the same way, and it shortens the process of filling in everything, because then you're just changing sizes and directions. One thing you need to know right away is the color codes on this sheet. Yellow cells are user lookup cells. Click on the cell and then click on the pull-down menu, then select an item. White cells require user input. Type input values directly into the cell. Green cells contain text cells, row and column headings, etc. They're locked and not accessible to the user. Blue cells are output formula cells, and they're locked and not accessible to the user. Orange cells hold subtotals or totals for heat loss and heat gain, and they're locked and not accessible to the user. Therefore, you got to put everything in right when you're doing the yellow and the white cells, because the other ones are not accessible, so you can't really force them to do what you want. Guess what? There's exceptions to every rule, and at the top of the form you have a slide down and a fill-in place that's not yellow, and so that's the only ones that you need to worry about at the very top of the form. And design, state, and city, if you clicked on that down there where the arrow is pointing, then something like this pops up and you can scroll down and pick your state. Next you pull down the city and you select your city, and some of the blue stuff starts filling in. We'll go over that a little bit more here in a second. Once the city and the state have been selected and the blue boxes fill in, you'll see that there's a bunch of initials on this thing. So you want to start getting familiar with the initials. HTD is heating temperature difference. CTD is cooling temperature difference. Daily range is some kind called DR, and it's low on this one. ACF is air correction factor, and it's 1 where it's sea level in this area. Elevation 18, grains different 73, latitude 30. And we have another thing there. It's the indoor design cooling relative humidity. Let's look at that a little closer. That one's a scroll down too, and you can select 45, 50, or 55. We generally recommend you go with 50. Now the next thing you need to fill in is the indoor design heating and the indoor design cooling. And 70 and 75 is what you want to select here unless the authority having jurisdiction causes you to need to put in something else to pass code requirements. Here's the J1 form, and I'm going to take a look at this bottom bar a little bit closer. We'll do a close-up on it. It's got the README, the J1 form, the summary, the glass schedule, doors, glass, walls, ceilings, floors, and there's a blue tab all the way at the end that's help, and then an orange one, what to do next. And that's the whole bottom form that we're going to be using and clicking on to fill in the values that then transfer to the front form, which is the J1 form. So basically it's backwards. You don't start with the front form, you start with the back forms, and you fill in the information you need, and then that information automatically is transferred to the next form you need, and then transferred eventually to the front form where you just fill in the areas, and then it does all the math for you based on what you filled in. Here's the one time you're going to see me go out of order. I'm going right to left along this bottom scroll bar with the exception of doors and glass. I'm going to do glass first because it's first on the manual N1 form. And we're going to fill out the glass. And if you click on the glass, and it pops up the table that you see below, and then you need to fill in the table values. And this is where you type in the table values or they won't appear anywhere else on the form. Now the first thing I'm going to do is type in the value, and let's say I've got a XXXXX window. Then what I want to do is I select that out of the table 2A, and you're not going to find that in 2A. I just put that in to show you that you can type in whatever's real and you find out there, and it'll go in there. And this is an example of the HTM that you can put in. That's really the new numbers that you have would be based on what is actually there. So if there was some kind of new window, you could actually put it in here and it would work. Next, you're going to go to table 2A, which is called the generic window and glass door defaults. And you're going to see that for the numbers for the type of windows, the generic windows and glass doors, that there's going to be a value, a U value. And so based on the type of unit, you're going to pick the U value. Now for my XXX, I have a U value that goes with it, and so I've placed that in here. Additionally, the next move is to go to table 3A in the textbook, and there you'll find your HTM values, or heat transfer multiplier values, for windows and glass doors and heat gain. And you look down at those tables in there and you select out the values that are applicable and put them into the form. Now at the bottom of the page in the glass schedule, and I didn't have enough room on here to show you the whole thing at once, but this is all one piece that attaches to the other piece on a computer, and you can scroll down to it, are population instructions for windows, glass doors, and skylights. And anytime you have any questions or you want to refer to filling out the form, this is the first place to look when you go down to the bottom of the page here. And you can look through these instructions if you have any questions or anything that you want to know, and they'll tell you exactly what you need to know to fill it out. Example is down here at the very bottom of the page. It's got a number 4. It says refer to table 3A for cooling HTM values for windows and glass doors. You can enter up to 5 different glass types for the vertical glass heat gain. Heat transfer multiplier values from table 3D-1 of the unabridged version of Manual J are valid entries. For example, and then it goes on, there's more stuff down there in examples. And at any rate, that's something that's important to remember, because if you get stumped a little bit, you can look at these and the directions will actually walk you through how to do it. As we go on down further, here's the values that are down below, the notes, construction attributes for windows and doors. And it's got all of the attributes and what you can do, and including the internal shade is none, blinds at 45 degrees, drapes or roller shade, half drawn, and all of these, if you'll recall, we're back in the rules. And so the rules are the defaults that are set in here, and this will remind you of what they are as you go for each individual section. Now we're making progress. We're moving over to glass schedule, and we're going to click on that at the bottom of the page, and then we're going to go to a scroll down here because it's a yellow tab, and we're going to scroll down and try and select our XXXX. Once we find the XXX and select it, then we can go on to the next step, which is to fill in the direction it faces, and then the height of the opening and the overhang distance and the type of opening overhang, and those all three get typed in. So that gives you what you have there. So if we look at this on the right, we'll see we have the height of the window, then we have the height above it, and we have the distance out, and this is going to give us shading values that are going to automatically be calculated by the form because we filled it in here. Now at the bottom of the page, again, we've got some reminders and stuff that we need to do and telling us some directions. So again, if you have any questions, look there first before you go off of the page, because it might tell you what you need to know to finish the form. This is where things really get cool if you're used to doing this longhand, because it automatically populates when you click on the J1 form, the J1 form. So our new window type comes up, and it comes up facing in the direction south, and it's XXXX, which we typed in, and that's the reason I use the X's. Now you can see it stands out when we start looking at this, and it doesn't mix in with the other ones. And so we got a heat transfer multiplier and a cooling transfer multiplier, and they're both there, and now we're ready to just start putting in the net area. Well, where would we put in the net area? We put it in over here in a white box, because that's where you type stuff in. Remember, white's where you type stuff in. And at the top, we've typed in master bedroom, because this is a whole house, and we're going to look at all the other rooms, and they go off to the right there on the form, and you can scroll over using a scroll bar at the bottom of the form to see those, and you can go up and down the form with a scroll bar on the right to move things up and down so you can see them on your page. And all of that makes it a little confusing when you're first starting, but after you've seen a few of them, it'll be crystal clear exactly what it does. So once we type in that 44, that gives us all the other values in the blue. They automatically populate as soon as we click off of it. So when we look at our values as they populate, we got a heating BTUs per hour of 1128 and a cooling BTUs per hour of 2420. And we have the exact same values for the master bedroom. Now the block load, which is the ones on the left there, if you look at the top of the column, it says block load right under the ACCA, and that will be the total. So if we had like 22 in this master bedroom of that window size and 22 in another room, then those two rooms would be half of the value, and they would add up to the block load, and that it becomes clearer as you go and look at it. But the bottom line is that if you have individual rooms, then you can put the same windows that are facing south in those rooms all the way across the line here, and then the values all add up to give you your total block load. Here we are, we're back at doors now, and from here on out we're going to go left to right, except we're going to skip over glass because we already did it. Now what we can see here is we have the type of door, and we have a U value, and we have our instructions, the population instructions down below here. And the input values are entered in the white cells, and the input values for wood and metal doors are extracted from table 4A. And ignore glass if glass area is less than 51% of the door. That's an important note to remember. What we're showing here is that I've entered the XXX again, so you can see it clearly when we get to the other tables. Now that would be normally a 4A table value, and then the 4A table corresponding U value would be entered here. Once again, you've got your notes at the bottom of the page that you can read if you have any problems or questions. Once we click on the J1 page, we got something slightly different, because we're going to look at the yellow scroll down here for the door, and we're going to scroll down and find our XXX and then select it. Once that XXX is selected, you can see that the heat transfer multipliers for heating and cooling are both already entered in a blue sheet. The rest of the blue will be entered after we fit the net area for the door. Here I've selected 32 square feet for the net area of the door. So we end up with 599 BTUs per hour heating and 544 BTU hours cooling based on our HTM numbers for heating and cooling. Now we move a little further to the right on our scroll bar at the bottom, and we click on walls, and up pops the wall worksheet. Once again, we get our values from table 4A, so let's just imagine that XXX is a value similar to the 12C, OSW frame R13, cavity insulation no board wood sheathing that we have above, and that our table 4A values are, the U value is 0.678, and then we have a group number with this type, and so we put in a group number. Once we completed our work table value, we go back to the J1 form, and this time again we scroll down to select, and we're going to select the XXX value, which automatically populates the heat transfer multipliers for heating and cooling. With the walls completed, we then go to the bottom of the table and we scroll across to ceilings and we click on them. And ceilings are just like everything else we've been doing. Once again we go to the table 4A and we grab the values and we plug them in. We get the U value, and the CLTD will automatically, we put that in there. And why is that one that we have to fill in? Well, because it may not be the same. In other words, the ceiling may be underneath a roof that's got a different temperature or something like that. But if our normal CLTDs work, then we use them. Once we got that done, we go back to J1 form and we plug in our XXX, and the two HTM values once again will appear. After we put in our net area, then the rest of the values fill in and the ceilings are completed. Obviously, if we have two different ceiling areas, one is like over bedrooms or something, and the other is a ceiling that goes all the way up to the rooftop in a large room, then we're going to have two different values, and we'll have two different areas for the rooms, and everything will be included in the block load. Now that we've finished with the ceilings, we're going to go on to the floors. Natural progression here, going to the right on the bottom, we click on floors, and voila, we open the table for floors. And we go in here and we plug in a XXX value for table 4A, and then we go to 4A table and we find a U value. And since this is a floor over enclosed unconditioned crawl space or basements, we got a temperature differential based on the outdoor air temperature, and that needs to be plugged in order to move on. We now click on the J1 form and we're back on the front page. We go to the yellow scroll down, we select XXX under passive floors, and we got HTM heating is 150 and cooling is 460, and we then get ready to plug in our net area again. Once the net area is plugged in, we have all our values for heating and cooling, and in this case we got 161 BTUs per hour for heating and 64 for cooling based on this floor load. From now on, we don't go off the J1 form. We just fill in what we have down at the bottom. And where we're going to start now is we're going to look at the number of fireplaces. That can be 1 through 3. We can look at envelope leakage. That can be tight, semi-tight, loose, semi-loose, and average. And in older homes, you probably want to use loose. You don't want to use average. And most homes, if they're really well built and they got wraps on them and they've been done by new standards, end up being average when you do a blower door test on them, unless somebody's done a whole lot of time and money trying to seal them up tighter. Additionally, we want to hit in the heated and cooled square footage, which is 1275, and then for 10-foot ceilings, 10 times that is 12,750 cubic feet. And then that will plug in some numbers there automatically in blue for us under the block load and for our room. Once we plug in the areas, we'll have it. The next line, internal gains, is line 13, and that's where most people hit their Waterloo. You know, that's where Napoleon lost, so this is where most people lose when they don't get an answer. They don't fill these two lines in properly, so pay attention here. The internal gains, we have 2400 BTUs for appliances, 1200 or 0, and those are the only options. For occupants, the number of bedrooms plus 1 is the number of occupants. Now when you look at that, the master bedroom has 2 here, so if we didn't have anything and this was a block load, we wouldn't get any answer for this because you have to put somebody in another bedroom. So you could put 3 in a master bedroom, you could put 3 in any other room in the house, and it would give you an answer. But if it doesn't equal 3, it's not going to work. So normally what you do is you take that 2 people and put them in a master bedroom and in a 2-bedroom house, and you put 1 person in the other bedroom. That way they're comfortable at night when they're sleeping because the cooling will work right. Now, having done that and put the 3 in 2 and having 3 in the other one, we also want to look at the appliance BTUs. They can go in whatever room they fit in. Now, obviously, in this particular case, the white block is just showing you where the block is. If you go scroll on across to the right, you'll see a utility room or a kitchen or someplace where you want to put the BTUs. But you can put 1200 in 2 different rooms. You can put 604 rooms. However you want to do it, it's got to add up to the 2400 if you select the 2400, or it's not going to give you a final answer. Next, we slide on down to duct losses and gains. Infiltration automatically fills in. It's an orange bar, so we don't do anything there. But we do have 3 scroll downs here, and we need to consider what type of ducts we have in a conditioned space or where they're at, and we need to figure out what our R value is, and we need to figure out what our leakage class is. And selecting from the scroll down selections, you can pick the proper one and click on it. Have one other thing we got to do. We got to select our installed square feet, or we can use a default of 1. And so in this case, I just use the default of 1 for the supply and return. We now have moved on down to ventilation and combustion air. We're down here on line 16, 19, and 20, and we don't have any furnace or water heater in this place. They're all electric, so we don't have that. We don't have to worry about that load. We got table 8A CFM for air coming in, and that gives us some numbers in blue. We got the manufacturer's performance data that has no blower heat discount, and so that gives us a little more cooling load because the heat from the blower is going to heat up the air a little bit as it goes through. And then line 20 automatically fills in orange, and it is 15,555 BTUs per hour of heating and 13,237 BTUs per hour of cooling. And all of that is sensible, so we still have to figure out what our latent is, and that's the next step. As we go down below here on the J1 form, we'll see our latent load information, and automatically we have some of it filled in from up above where it was calculating latent all the way along, and those are in blue. And then we have a load for houseplants that we could put in or not put in, and I don't have any houseplants in this place, but you can put in small ones, medium ones, and large ones, and then it figures out how much moisture they put out into the air. Then you have a latent load for duct and unconditioned space, and we didn't have that. It's in conditioned space. And we have a latent load for cooling, and it's given us that. And then we got a total latent gain of 4292. And so what we have then is our cooling BTUs, our total BTUs is our 13,237 plus our 4292. Down here on the bottom left is where you enter in your company name and address and all the information you want to be on a sheet when you print it out. Because all you have to do now is hit the print button, and you're going to print copies of two sheets. You're going to print one, which is the manual JAE sheet, and the other, which is a summary sheet. Now the summary sheet will print out all the bedrooms and bathrooms and rooms in the house and what the CFM value is for it. Now if you want to put an override in there and plug back in a CFM once you do your equipment selection, it'll automatically change all those numbers to match your equipment selection, so you don't have to figure out how to balance it again. It'll all be figured out for you on the sheet. These two sheets can then be turned in, and you have what you need to get a permit in most areas of the country. The only question remaining now is, what do you do next? Well, you use manual S for the equipment selection, you use manual T and OEM data for diffusers and grills, and you use manual D for the duct design. You comply with all applicable codes, and you use industry certified methods and materials. And then everything will work perfectly, and your customers won't complain, and you'll be a happy camper. So if you have any questions, please contact me. My name is Don Prather, and I'm Technical Services Manager at ACCA. My phone number is 703-824-8867, and my email is donald.prather@acca.org. If you have any way to make this presentation better or any questions based on this presentation, feel free to call me.